Hello again. We are continuing our discussion of factoring polynomials, and I want to talk about a very specific case today, and that is talking about differences of squares. We're going to talk about what that looks like and how to factor those. So I want you to remember multiplying a binomial and its conjugate. We talked about that in a previous chapter. So if I had x plus 12 times x minus 12, that would be x squared minus 12x plus 12x minus 144. And if you remember, those x's in the middle could cancel out, and I would be left with x squared minus 144. If I had 2a plus 5 times 2a minus 5, and I multiplied that out, I would get 4a squared minus 10a plus 10a minus 25. And remember, again, the middle terms would cancel, and I'd be left with 4a squared minus 25. Last one, if I have 9pq plus 1 times 9pq minus 1, that multiplies to give 81p squared q squared minus 9pq plus 9pq minus 1, and that simplifies to give 81p squared u squared minus 1. Okay, so I want you to see if you can see a pattern between the question you were asked and the answer that you got when you're multiplying, because we have to work backwards. So what you'll realize if you look at these examples is that the answer is always going to be two perfect squares that are being subtracted. Okay, and I can write that as something squared minus something else squared, or a squared minus b squared. And so when I want to work backwards, what I will end up with is the first thing plus the second thing times the first thing minus the second thing, which can be written as a plus b times a minus b. Your job is to figure out what a and b actually are. So the factorization of a squared minus b squared is a plus b times a minus b. All right, so here's some examples. 25b squared minus 36. So I do have two perfect squares that are being subtracted, so this is a difference of squares. So I figure out the square root of each part. 25b squared is 5b squared. Okay, 36 is 6 squared. So they are being subtracted. This is a difference of squares, so I can factor it as 5b plus 6 times 5b minus 6. Okay, if I had 81x to the 6 minus 169, if I square root each part, the first part becomes 9x to the third, and the second part becomes 13. There is a minus in the middle, so this is a difference of squares, so the factorization is 9x cubed plus 13 times 9x cubed minus 13. It really doesn't matter which set of parentheses gets the plus and which one gets the minus, as long as they're different. So here's a geometric explanation of what's going on. Why is it that a squared minus b squared equals a plus b times a minus b? Well, if I have a squared minus b squared, then there's a big square that is a by a, and there's a little square that is b by b, and that's being cut out of it. So what I'm going to do, the rest of that top is whatever a was minus whatever b was. So that's the remaining width across the top. So what I'm going to do, I'm going to move this shape around so that it's a rectangle, and what you'll notice is that B section gets moved to the bottom. So what you'll notice is that length along the side is an A and a B, which we can write as A plus B, and the width along the top is A minus B. So that is why if I have A squared minus B squared, then the factorization is A plus B times A minus B. Okay? So hopefully that explains it for you. Sometimes these can be in disguise. You'll see things being subtracted that don't look like perfect squares, but that means that we may have to do a little bit of work first. All right, so let's say I have w to the third plus 7w squared minus 4w minus 28. Well, what I can do is I can factor each pair. So for the first pair, I can factor out a w squared, leaving me with w plus 7 in parentheses. And from the second pair, I can factor out a negative 4, leaving me with w plus 7 in parentheses. Both of those have a w plus 7 in parentheses, which can be factored out, leaving me with w squared minus 4. Now, w squared minus 4 is a difference of squares because w squared is a perfect square and 4 is a perfect square, and they are being subtracted. So if I figure out the square root of each part, then I can write the factorization as w plus 7, which is what I had before, and then that w squared minus 4 can be written as w plus 2 times w minus 2. Here's another example where I have 18h to the third minus 50h. Neither of those are perfect squares, But I do know that 2h can be factored out of each of them. And if I do that, the first term becomes 9h squared and the second term becomes 25. 9h squared minus 25 is a difference of squares because I know the square root of 9h squared, that's 3h. I know the square root of 25, that's 5. They are being subtracted, so my factorization is the 2h that I had at the beginning times 3h plus 5 times 3h minus 5. So just be aware that when I'm asking you to do a difference of squares, there may have been something else done to it afterwards that you may have to factor out. You may have to work on it a little bit before you apply this rule. If you have any questions about this, please let me know, and I will see you tomorrow.